हेलो एंड वेलकम बैक। इस वीडियो में हम लोग कुछ क्वेश्चन डिस्कस करेंगे जो ग्राफ बेस्ड है। इसमें ये नॉलेज होना चाहिए कि तुम कोई ग्राफ अगर गिवन है तो उस बेसिस पे गिवन अननोन को कैसे निकालते हो। सो लेट अस डिस्कस couple of numericals based on graph in case of one-dimensional motion. First question. A graph of position versus time for a boy traveling in positive x direction is displayed in figure. Find average velocity for following cases. So it's x versus t graph. So as far as average velocity is concerned, you know average velocity is equal to displacement, that is delta x by delta t, and you can easily find out delta x for given delta t from graph by direct observation. For example, at t equal to 2 second and at t equal to 4 second, you know x coordinates, it is 4 and 16. So delta x is 16 minus 4, that is 12, divided by delta t is 2. So put values here, you will get desired unknown. So for part B and part C you can do same thing. Next question. The position time graph for particle moving along x-axis is shown in figure. Determine whether velocity is positive, negative or 0 at these times. So from position time graph we can find velocity, because v is equal to dx by dt, and this means first derivative means slope of tangent. You can easily find sine of slope. So first draw tangent at these times t1, t2, t3, t4, t5 and t6. Tangent at t2, t3, t4, t5 and t6. Now find out sine of slope of these tangents. So slope for this is negative, this one is 0, this one is positive 0, this also is 0 because it is parallel to time axis, and slope of this one is negative. So it's a very simple question. Next question. The graph shows velocity of a runner plotted as function of time. What is interval where velocity of runner increases rapidly, decreases rapidly and stays constant? So by direct observation you can answer that it increases rapidly, decreases rapidly, and in this and this it remains constant. Next, how far does the runner whose VT graph is shown in the previous exercise travel in 8 seconds if at t equal to 0 x was 0? For question 4 we have to find area under this graph from 0 to 8 seconds. So you can find this area by dividing this total into smaller areas. So this triangle, rectangle, you can take trapezium also, or you can divide it into triangle and rectangle. So 1, 2, 3, 4, 5 and 6. Find out area of this definite geometrical shape and add them. You will get desired unknown. Next question. A particle has x equal to 0 at t equal to 0 and velocity as function of time is shown in figure. Find average acceleration, time interval is given, and find acceleration at t equal to 4 seconds. So as you know, from velocity time graph we can find each and every variable. As far as average acceleration is concerned, it is v2 minus v1 by t2 minus t1. So by direct observation you can find this out. At 5 second, velocity is minus 4, and at t equal to 0 velocity is 0. So this is equal to minus 4 by 5 meter per second square. And to find part B, instantaneous acceleration or simply acceleration at 4 seconds, we need to find slope of this line, because a is dv by dt and first derivative geometrically is slope. So to find slope, draw this triangle. You know this is 6 plus 4, that is 10, divided by base is 5 minus 3 2. So 10 by 2 is equal to 5 meter per second square. And what will be sine of this slope? Sine is negative, so it is minus 5 meter per second square. Next question. The feast begins at rest at the waist and is brought rapidly forward until the arm is fully extended. The speed of the feast is given in figure for someone skilled in karate. The vertical scaling is set by this. How far has the feast moved at t equal to 50 millisecond and when speed of feast is maximum? So in both the part we have to find distance travel. As graph is VT graph, so by finding area we can find, so in part A we'll find this area up to 50 millisecond, and for part B, now this is your maximum speed. So this maximum speed is at, this is 100, 110, 120, this time is 120 millisecond. So we'll find area from 0 to 120 millisecond. This area will give you distance travel in part B. Find this out. You can easily find this area by dividing this into smaller areas. Next question. When soccer ball is kicked toward a player and the player deflects the ball by heading it, the acceleration of head during collision can be significant. Figure gives the measured acceleration of soccer player head for a bare and helmeted head starting from rest. The scaling on vertical axis is this much. Time equal to 7 millisecond. What is different in speed acquired by bare head and speed acquired by helmeted head? So we have to find speed, and area versus time graph is given. So as you know, V is equal to integral A dt. So we need to find area. So to find speed of bare head, we will find out this area. You can divide this into smaller areas. So this is area 1. And as far as helmeted head is concerned, this area is velocity for helmeted head, that is A2. So the difference is difference of area. So difference in speed is equal to A1 minus A2, or by finding out this area between these two lines, you can also find out this difference. Next question. How far does the runner whose velocity time graph is shown in figure travel in 16 seconds? Vertical scaling is set by this. So it's a VT graph. We have to find distance. So find this area. We can divide this area into smaller areas. This is area 1, this is area 2, this is area 3, a trapezium, and finally area 4. So find out individual areas. A1 is equal to half into base into height. Half into base is, this is 4 seconds, so this is 2 seconds. Half into 2 into vertical scale is set by 8, so this is 8 meter. A2 is a rectangle, area 2 is a rectangle. One's dimension is 8, another one is also 8. So 8 into 8 is equal to 64. Unit is meter, mind you. Now third is a trapezium. So area of trapezium is half into sum of parallel sides. So one side is, this one is 8, another one is 4. So this is 4, this is 8, and distance between parallel side is 2. So this is 12 meter. And 4, shape 4 is a rectangle. Area is, this dimension is 4, this one also is 4. So 4 into 4 gives you 16. Add them. So this comes out to be 100 meter. This is desired unknown. Next question. Figure gives acceleration versus time for a particle moving along an x-axis. Acceleration axis is set by this value. At t equal to minus 2 seconds, the particle velocity is 7 meter per second. What is its velocity at 6 seconds? So graph is AT graph. We know velocity at minus 2 seconds. As you know, v is equal to integral a dt. But when you will take limit, it should be written as delta v, and time from t1 to t2. In this case our limit is from -2 to 6 second. So limit is -2 to 6 second. So we'll find area from -2 to 6 second. So first shade this area. As we have to find velocity, so we need to take into account sine of area also. So area 1 and area 2. Area 1 is that of a triangle. Half into base is -2 plus 4, that is 6, into this is given as 12. So this is 36 meter per second. Unit will be that of velocity. And area 2, this area is a triangle. That area is half into 2 into 4, and sine of this area will be negative. So total is delta V is equal to 36 minus 4, 32, and delta V is V minus initial velocity. Initial velocity is 7 meter per second. So this comes out to be 39 meter per second. So you make mistake in this. Whenever you use, instead of using V equal to integral A dt, you should use delta V equal to integral A dt. Then you will not make mistakes. Next question. A particle starts from origin at t equal to 0 and moves along positive x-axis. A graph of velocity of particle as function of time is shown in figure. What is coordinate of particle at 5 seconds? What is velocity at 5 seconds? What is acceleration at 5 seconds? What is average velocity between 1 and 5 seconds? What is average acceleration of particle between 1 and 5 seconds? As graph is velocity versus time. So from this graph you can find each and every variable. So I don't think any discussion is required here. Very easily you can find coordinate, that is position. So find position, you will find area. Velocity you will find from direct observation. Acceleration by finding slope. Average velocity, so at 1 second and 5 seconds you need to know position. Position you can find by finding area. And average acceleration from direct observation, v2 minus v1 by t2 minus t1. Next question. Attaches a GPS collar to track its movement. The collar transmits data on tiger's position and velocity. Figure shows tiger's velocity as function of time. So it's a velocity time graph. At which marked point is tiger not moving? Not moving means velocity is 0. So from direct observation you can find that. So at these points velocity is 0. So correct option is B. Second, at which marked point is tiger not accelerating? So slope. So at C and F slope is 0. At which point does the tiger have greatest speed? Greatest speed is at C. At which point does the tiger's acceleration have greatest magnitude? So slope has maximum value. So by direct observation, if you draw tangent at D, the slope has greatest magnitude, that will be more steep. Next part, at which point is tiger farthest from starting position at t equal to 0? So at this position you have a turning point because velocity is 0 and this half velocity is negative. So farthest position is when tiger is at turning point, so that is E. So this area. So answer is B. Next question. Figure shows velocity graph of a particle having initial position 0 at t equal to 0. At what time or times is particle found at 35 meter? So velocity time graph is given and we have to find position. And mind you, velocity is 0, positive, negative, so you have turning point also. Let us first find out this area. This area is half into 8 into 10, that is 40 meter, and we have to find position 35 meter. So trial and error, how much will be this area? Half into 2 into 5 equal to 5. So from 0 to 6 second, area is equal to 35 meter. 0 to 6, area is equal to 35 meter. So one time is 6 second when position is 35 meter. Is other time possible? Now when x is equal to 40 meter, particle turns back, so again it will come to that position 35 meter. So consider this area is negative. This at 8 second position is 40 meter. This is turning point, so we need minus 5 meter. So how much is this area? Minus 5. So from 8 to 10 second, so at t equal to 10 second, position is again 35 meter. So position is 35 meter at t equal to 6 and 10 second. This is desired unknown. Next question. Particles A, B and C move along x-axis. Particle C has initial velocity 10 meter per second. In figure, graph of A is position versus time, B is velocity time, and C is acceleration time graph. Find each particle's velocity at 7 seconds. So one is position time, another one is velocity time, third one is acceleration time. So for particle A, as you know, velocity is dx by dt, so we need to find slope, and we have to find velocity at 7 seconds. So find slope of this line. So let us consider this segment. This is 30, this is 3, so slope is 30 by 3, and as far as sign of this slope is concerned, it is negative. So velocity of particle A is minus 10 meter per second. For particle B, it's a velocity time graph, so we can find velocity by direct observation. So at 7 second, velocity is minus 20 meter per second. So this is your velocity at 7 second. For particle C, we have acceleration time graph. So to find velocity from acceleration time graph, we need to find area. So delta V, don't say V equal to integral A dt. What I have advised you, delta V equal to integral A dt, and limit from 0 to 7 second. Find out this area, and delta V will write as V minus initial velocity is 10, so V minus 10 is equal to this area. This is a trapezium, area 1 and area 2. This shape is a triangle. This sign is positive, this area has negative sign. So A1 is equal to half into sum of parallel sides, that is 2 plus 5. So half into 5 plus 2 into distance between parallel side is 30. This is equal to 105 meter per second. And area 2, area of triangle is half into base is 5 to 7, that is 2, and height is 20. So this is equal to 20 meter per second, and sign of area is minus. So V minus 10 becomes equal to 105 minus 20. So V minus 10 is equal to 85. So V is equal to 85 plus 10 equal to 95 meter per second. This is desired unknown. Next question. Figure shows acceleration versus time graph particle moving along x-axis. Its initial velocity is this much. What is particle's velocity at 4 seconds? So AT graph is given. We need to find area. So instead of v equal to integral a dt, delta v equal to integral a dt. So we have to find this area from 0 to 4 second, between 0 to 4 second, and delta v is v minus 8. So v minus 8 is equal to this area, and this area is equal to half into 4 into 4, and sign is positive. So v minus 8 is equal to 8. So v is equal to 16 meter per second is desired unknown. Next question, figure shows velocity versus time graph of a particle. Its initial position is 2 meter at t equal to 0. Particle position, velocity, acceleration at 1 second, and position, velocity, acceleration at 3 seconds. So it's a velocity time graph. We can find each and every variable. So as far as velocity at 1 second is concerned, it is simply 4 meter per second. And as this line is parallel to time axis, so acceleration is 0. And to find position, we'll use delta x equal to integral v dt instead of x equal to integral v dt. So this area, so from 0 to 1 second, area is that of shaded region, which is 4, and delta x is x minus 2. So x minus 2 is equal to 4. So x is equal to 6 meter. Similarly, part B, we need to find position, velocity, acceleration at 3 seconds. So as far as velocity is concerned, that you know from direct observation, at 3 second velocity is equal to 2 meter per second. To find acceleration, we need to find slope. Consider this triangle. So how much is slope? 4 by 2. This side is 4, this is 2, and sign will be negative. Sign is negative, so it is minus 2 meter per second square. Now to find position, use this delta x equal to integral v dt, and this v for delta x, write x minus 2 and find out this area from 0 to 3 second. This area plus this area, one is rectangle, another one is trapezium. So area of rectangle is 8, and that of trapezium is half into sum of parallel sides, that is 4 plus 2 into 1 equal to 8 plus 3 equal to 11. So x minus 2 is 11. So x is equal to 13 meter. This is your desired unknown.